Hi, good morning. Welcome to our Honors Geometry 4.6 notes, isosceles and equilateral triangles. So a quick reminder that equilateral triangles have 3 congruent sides. And isosceles triangles, we said, have exactly 2 congruent sides. Now, some textbooks will say at least 2 congruent sides, so you can make an argument for either one. But at least in our class, we took a vote. We agreed that we thought it should be exactly 2 congruent sides. So our isosceles triangle theorem. The isosceles triangle theorem says that if 2 sides of a triangle are congruent, then we know that 2 angles of the triangle are congruent. So if I have 2 sides of the triangle are congruent, then I've got 2 angles. And conversely, if 2 angles of a triangle are congruent, then 2 sides are congruent. So our converse there, again, if 2 angles are congruent, then 2 sides are congruent. Or if 2 sides are congruent, then 2 angles must be congruent. So an example here would be, let me pull that up really quickly. If I had a triangle, I'm going to name this A, D, C. And then I'll mark B over here. So I'm given that angle ACB, which is right here, is opposite of side AB. So when you're trying to identify what sides and what angles are congruent in your isosceles triangle, the angle that opens up to the opposite side is going to determine what sides are congruent. So this angle here opens up to side AB, so AB is marked as congruent. Angle ABC is opposite or across from side AC. So if I have, that's not what I wanted to do. Why does it? Oh, that's why. So if I had, for example, just maybe one triangle. Here's my one triangle. Angle D is opposite of side AC, so I know that's one of my 2 congruent sides. And angle C is opposite of side AD, so I know that's one of my 2 congruent sides. So your congruent sides will always be opposite the congruent angles. And if you draw an arrow that bisects one of those given angles, you'll get to the opposite side, and that will tell you what sides are congruent. So for example, in this triangle, it also works in the opposite direction. That if you have a side that is congruent, the angle that is opposite that side could be marked in. So angle C is opposite side AB. I can mark that in. And angle B is opposite side AC, so I can mark in angle B. Which means that the measure of angle D is congruent to the measure, or I guess angle D rather, would be congruent to angle DCA, and that would be congruent to angle ABC. So all of these angles are congruent, and ABC is congruent to measure of angle ACB. So I have 4 angles there that are congruent, all of those marked in blue. And that also means I can mark in side AD, because side AD is across from one of my marked angles. Okay. So referring to the triangle at the right, AC is congruent to AD. So let's figure out what angles are equal. So if that's true, what angle is across from this side? Well, if I go straight across from that side, I get to angle D. So angle D. And then we were told that AD was a side here. So in my big triangle, angle ACD is the other congruent angle. So maybe I should name this ADC and ACD. All right, let's take a look at our 2 angles. If I gave you that EBA, where is that? That's here, was congruent to EAB. Those are equal. What are the 2 sides? And maybe it would help me if I kind of cover up or ignore everything else that's not in that triangle. If those 2 angles are equal, what sides have to be equal? Well, what side is directly across from angle B here, or angle EBA? That would be side AE. And side AE is congruent to, well, what side is opposite angle A here, or angle EAB? That would be side BE over here. That would be opposite of angle EAB. So if you have congruent angles, you have congruent sides. If you have congruent sides, then the opposite angles are congruent. It works both ways. You just need to be able to identify where are my opposite sides and where are my opposite angles. So some corollaries here. A triangle is equilateral if and only if it is equiangular. Okay, how does that work? Well, think of your isosceles triangle theorem that we just learned. If I have these 2 sides are equal, well, then I know that those 2 angles are equal. But hold on, what if I throw in that 3rd side? Well, now I've got these 2 sides are equal, which means that these 2 angles have to be equal. Okay, and you can keep going around the triangle like that. You can say, okay, well, what if I have these 2 sides? Well, if those 2 sides are equal, then the opposite angles must be equal. So as long as it's equilateral, you have an equiangular triangle. And each measure of that triangle would have to be 60 degrees. All right, let's look at some examples. We'll do 6 examples, and then we'll talk about some CPCTC. I'll show you 2 proof examples, and then you try 2 on your own. So if you feel confident with these, just skip through it. Notice that you've got 2 sides that are equal. The angles that are across from those sides are 75 and x, which means that these 2 angles must be equal. So 75 equals x. All right, on B, That's the angle across from my marked side. Here's the angle across from my marked side at B. So B must be 60 degrees as well. And now if I wanted to find the third angle, of course I could do that, and I would get 180 minus 60 gets you another 60. And 180 minus 75 on that first example would get me 30 degrees. All right, let's look at C. What two angles are equal? It's the ones across from my marked sides. So up here I have 54 degrees, which means to find x, I would have to take 180 minus 108, and I would get that x is 72 degrees. And D's probably the most challenging one out of these, out of this first group at least, because my congruent angles, neither one of them is marked. So if I have some unknowns, I can put x for one of these. But hold on, I know that these are equal, which means that the other one must be x. And I know that my three angles should add up to 180. So if you want to pause the video before I give you the answer, you should do that now. And x should be 70. All right, again, the big key idea is here, identifying what parts are really equal. This one was kind of nice. I gave you the two sides opposite the congruent angles, which means that 2x plus 4 really should be equal to 3x minus 10, which means that x, you could solve for that pretty quickly. And on B, what angles are equal? There's one, there's the other. So if these two things are equal, I've got 90 degrees up top. I've got 2x plus 3 in the one corner. And if those two angles are equal that are highlighted, the other one should also be 2x plus 3. And I know if I add those up, I should get 180. And you could solve for x from there. Okay. Our last proof type, here we've got CP-CP-C, which means that if two triangles are congruent, then the corresponding parts, that's the first part here, corresponding, that's the C, parts of congruent triangles are congruent. Okay, what does that mean? My C, P, C, T, C. It means that once I prove that two triangles are congruent, like if I prove one triangle A, B, C is really congruent to triangle D, E, F, then I know that A should be congruent to D. I know that AC should be congruent to DF. I know that BC should be congruent to EF. I know that all those corresponding parts are equal. So step one is going to be to prove, just like normal, that the triangles are equal or congruent. And then once I've proven, so maybe I'll put a step in here, prove congruent triangles first, just like we have done. And then my final step is going to be this, by that theorem. So as always, first step, givens. Second step, what I want to do is I want to look at my triangles here. And you know what? Maybe we should skip example 4 for right now. Let's go to example 5. I lied. Let's go to example 5 first. I want to prove angle R is congruent to, let's go RSV is congruent to angle TSV by that corresponding parts theorem. So step 1, still your givens. Step 2, again, we're just trying to prove congruent triangles right now. If V is the midpoint of RT, then you can say RV is congruent to TV by the definition of midpoint. And then step 3, SV should be congruent to SV by the reflexive property and now I've got congruent triangles. So triangle RSV is congruent to triangle TSV by side, side, side. But I'm not done. Now, normally that's where we would have stopped. The only new thing for today is to say that if I have congruent triangles, then any corresponding parts that I want, you could pick whatever corresponding parts you want. It's just here I chose those two angles. But any corresponding parts would be equal or congruent because corresponding parts of congruent triangles are congruent. What I would ask you to do is to try those other proofs, check your answers with the answer key provided on the Google Classroom page, and I will see you on Monday.